I got the fortunate position of following Mayor Daley, so that was a good thing. And also the fortunate position of following so many great presentations the last day and a half. I am truly humbled by what I have seen here in this day and a half. It is amazing what you see, the efforts that people go through, the time and the things that happen. And as a supplier to this industry or to this effort of building tall buildings, I really am encouraged by the work and the due diligence, the education, the learning that takes place in these buildings. I wish the rest of the industry would be as good, because as I prepared for this speech today, I actually came in here to want to talk about some of the misconceptions, and I'll still do that, but I would say to you that they clearly are less prone to being used in these kinds of mega projects where people are doing their due diligence. So very happy to be here and to be a part of that. The thing that I'd like to talk about in terms of glass and aluminum, and certainly we've heard about other products, metal products that could be used in commercial buildings, but they really are the most economical environmental filters. And we really look at the use of glass and aluminum to do that. I know that for the most part, the most important part of glass and aluminum on high-rise buildings is the aesthetics. And we certainly understand that as a company. Viracon is very proud to be the leading supplier of glass to tall buildings. In fact, have supplied nearly half of the top 20 tall buildings in the world, and continues to be a leader in that category. What we really want to do, though, is to make sure also that you understand that the use of glass and metal is, as I came into this conference, there was some news releases and other things that talked about buildings not performing to the way they should be, and I want to address that. And I'd like to clearly make a case that it's not the glass and metal that's led to these buildings underperforming from an energy standpoint, and we'll get into some of those kinds of details. The first two misconceptions that are most common that I run into a lot are the use of triple glazing and building integrated photovoltaics. Now, there are exceptions to both of these, and I'm not here to tell you that you should never do either of these. In fact, we're very happy to do it, and as a company, we've probably installed more building integrated photovoltaics and more triple glazing, manufactured more for high-rise buildings than any other company. We're happy to do so. There are applications where it makes a lot of sense, where it's good economic sense as well as good business sense to do this. But I think that one of the things we've seen in the industry is sort of an overreaction to a few good points on these. And the point is that only really in the coldest of climates are really that triple glazing and these things are needed. It's usually in buildings where there's high humidity or a need for that, or there are special considerations. And clearly in those applications, these kinds of products make a lot of sense. What I would say to you that in tall buildings, because they cast a long shadow, and that means that they're intercepting a large amount of solar energy. And solar energy is quite intense. The sun puts 100 watts of energy per square foot, 1,000 watts per square meter onto the sides of buildings when they're in the daytime. Now, fortunately, the sun moves around, so you only get that at a portion of the day all the way around the building. But that's a very intense amount of energy that's coming into these buildings. And it's really the use of the natural energy and the plug loads, the people, the other things that are going on inside of commercial buildings that can supply plenty of heat to commercial buildings. And that's a misnomer. I know that the people in this audience understand that more so than others, but it is one of the things that leads to some of the kinds of things that we do talk about. And in fact, if you do have a building that needs a lot of heat today throughout most of the US, it's probably due to the fact that it has monolithic glass, non-thermally broken metal systems, and most importantly, it probably leaks a lot of air. And I think that the first two are clearly understood. I know a lot of people here have talked about those. But the third one, the opportunity for the wall to leak a lot of air and to make people uncomfortable, I think is very misunderstood and needs to be a part of it. I think we got into that a few years ago in the industry, and we fixed that problem, but then specifications stopped talking about it, and I think it's crept back into it. So it's one thing I just ask you to look for. Building integrated photovoltaics. When we talk about building integrated photovoltaics, and I can tell you that as a company, we've invested heavily into this, and we've done a lot of work with building integrated PV. What we find, and what I would tell you is that we really can't make it economically viable. We can demonstrate it, we do it, we know how to put the wires in, make it compatible with curtain walls so that, remember curtain walls leak. There's water that comes in that has to be reshed. And mixing water and wires is not an easy challenge, but yet we're able to do that. But what I would tell you, when we're looking at sustainability of commercial buildings today, and there were earlier questions about this and putting some of these features in commercial buildings, I would urge you as you're designing the future commercial buildings to understand your costs of doing these things and look at the total picture of what's going on. I'm really excited to see that people are not just talking about the buildings today, but they're talking about the surrounding areas, how they're fitting in with that, what they can do there that can make more of it. I think we need to expand that. When these projects go in and we're worried about the energy these buildings consume, and we want to offset that, we can do that much more economically by doing that as part of the project, not part of the building. And I think that's a very important point that I wanted to get across today so that people could understand it. Quite frankly, the simplest way to describe this is when you go out to get a suntan, you don't stand up. You lay down because the sun's intensity gives you that tan. And the same thing is true with building integrated photovoltaics. You can't stand them up and expect them to be an economic driver. I think that this chart is really interesting because it really outlines the problems that we're talking about. 100 square feet can generate in today's photovoltaic panels about 15 watts. It's really between the thin films, the nanotechnology is about 10 watts per square foot, the polysilicon crystal is about 15 watts per square foot of electricity. And so as that electricity then is brought into the building and we put it through the most efficient lighting system we could, something that's 30% efficient, an LED system, we might get 3 watts of light out of that 100 watts of energy. We are far better off in designing our buildings of the future to harvest light and to bring the light to the interiors in its natural form. And in doing so, it's been clear that some of the leading studies have indicated we only need to harvest about 5% of the incidental light that comes from the sun to bring it to the interiors to have an effect, a meaningful effect, and to reduce the energy required to light buildings. And in doing so, that really, the use of interior light shelves, when we're talking about this energy, remember only half of this energy is light and half is infrared. So you have 50 watts of light striking this. If we can redirect some portion of that and dim these, we've done a major job in reducing the energy consumption of commercial buildings. We have to remember, in the United States today, this is an amazing statistic that it just drives me crazy every time I hear it. Over 40% of the electricity generated in the United States is consumed by commercial buildings. Almost half of that energy is used to cool and light those buildings. It's an amazing statistic. So the better we can control the lighting and the air conditioning, notice I didn't say heating, lighting and air conditioning of these tall, intensive buildings, the better we're able to make them, to reduce their use of energy. And of course, the best electron we can ever generate is the one we save, the one we don't use. So when we want to reduce carbon emissions and other things, that's the best way to go after it. Okay, let me get back to, so I've gotten through the misconceptions and a couple of the points I wanted to make. So why glass and aluminum? It's cost competitive. That's why. It's a great product. We can do this, and if I have one more point I want to provide, is that I think that the use of glass and aluminum, it should be the basis. I'm not here to tell anybody to limit your design to glass and aluminum or how to design. Believe me, I'm not the design specialist. What we are as a company, why is Viracon so successful? Because as you create designs, as you create concepts and you have ideas of what you want to do, we're able to provide the products that meet those requirements and in fact even create them if we need to, while they are very energy efficient. And that's the key thing that we do for these. So it's the economical use of these that provides substantial value in terms of supporting your design concept and making the buildings as energy efficient as we possibly can. I talked earlier about some of the problem buildings. There are many. It's really sad that there are buildings still being built today that aren't energy efficient, or they're not paying attention to air infiltration. I feel good from the things I've heard at this conference that the major buildings they got it. This audience gets it. That's a great thing. But I can tell you that there are many who don't, and I think it's certainly when we talk about learning and communications and things to the industry, we need to continue to do that. There are many good buildings, and I think that that's important, that they're well erected, well designed, they meet energy expectations. If it's a LEED building, you would expect it, a LEED certified building, you would expect it to perform. Unfortunately, there are many today that don't. And I think that it's very important that we understand what it takes to make these buildings perform and we get to them. So what's the difference? Air and water, especially in older buildings, it's really, in an old building, people have asked me, what's wrong with the building? And I'll sort of ask them, I said, what do you see when you walk in on a very cold day or a very hot day? Because it's the extremes that sort of answer the question of what needs to be done or what's wrong with the building. If it's a very cold day in Chicago and you see ice on the bottom of the windows and the frames, you probably have three things wrong. You probably have bad air infiltration, non-thermally broken, and likely single pane clear or tinted glass. If you're very hot on a hot day, you probably have non-spectrally selective coatings, and we'll get more into that. You probably have high light transmission, high infrared transmission. Those are the kinds of things that force us to close the blinds and turn the air conditioning up. So it's the filtering characteristics then that I'll get into that really help us to meet the energy needs, the balance, the comfort that we want to have in buildings. Air and water shouldn't be a problem. Standards are there, and they need to be enforced and tested. That's a responsibility of people building buildings. Value of glass. The number one thing is design. I said that earlier. Too often we let design go without the consideration of the energy aspects. We can meet those, and I think that's one of the reasons why we've been very important about this. So design does not have to be non-energy efficient. It can be, and we really want to support that. Glass is a great controller of air and water. Clear glass, it's interesting. We love clear glass because we can see through it, yet it is a terrible filter. It lets through everything. It lets through gamma rays, alpha rays, beta rays, microwaves, light, infrared energy, UV, they all go through. And so when we begin to enclose buildings today, we understand, and that's one of the things that we bring to the marketplace, we use nanotechnologies of developing thin film optics that create filters for the unwanted spectrums of this solar energy and these different types of energy that come through glass. And that's where we are able to really bring to market what it is that makes you successful in designing. Spectrally selective coatings, they really are, the objective today in design is to optimize the visible lighting so that we can harvest that to do our task, minimize the artificial lighting, and then eliminate the thermal transfer. We can do this and meet design goals at the same time. Now, we can't violate the laws of physics. I can't give you 100% light and a shading coefficient of 0.2. That's impossible. We can't do that. But we can very nearly give you a 50% light and 25 and a shading coefficient of 0.25. That we can do, and that's an industry-leading standard that we've set in the marketplace today. So there are things that we can do in combining them with thermally broken aluminum systems, really set the stage for your thought process. And this thought process is one of understand what the best value is, and then be creative in your design and understand the economics of what my design changes make to this. And design changes have all kinds of value. There is no question that you can create value with design. I appreciate that very much. But understand what the cost is and what value you're creating. That's what we think you can do by starting with a standard high-performance, thermally broken system, and then be creative beyond that. Tall buildings cast long shadows, understanding their needs. It really is about comfort. And it's the summer and winter comfort that we want to be used to. Understanding the energy type, what we can do to control that, all of that's important to the occupants, to the cost. And the other thing I caution people is that measuring comfort is actually something that's difficult. I think you have to look at where your building is, what the latitudes, what you're doing in that building to understand the comfort factors. And then it is important to design to those. And there are things that we can do in glass and metal to help you meet those design optimizations. Natural light should be harvested. Excessive light causes glare. You can't see your computer screens. You're putting in expensive fixes of blinds. I think it is a shame that on the most beautiful day of the year, when the sun's shining and you have the greatest view out of your window, that we build buildings where we have to pull the blinds down. I just think that's a horrible shame. We should be enjoying the view on the best of days, not hiding the view. And I think it's very important that we understand that as we design, as we look at our buildings and we look at what we can do. Again, the solar infrared energy needs to be eliminated from tall buildings and controlling the visible light. I'm quickly going to go through this. Department of Energy says that they use an effective aperture. I've got the equation here. I know you've got copies of it. But fundamentally what that means is that light transmission in an all-glass building where you have floor-to-ceiling glass should be about 20 to 40%, 20 to 50%, depending on latitude, building orientation, and other things of where they are. And it's really this use, a proper use of light that's critical. Remember, I said almost half the energy generated, electricity, is used in commercial buildings, and almost half of that is to light them and cool them. And if we're adding to that cooling load by letting too much light in, we're actually not being very green. And we have to understand the trade-offs that are going on when we do that. So visible light should provide, and visible light should be the only component of solar load in commercial buildings, again, because they're natural heat generators. Suggestions for tall buildings. Glass can certainly help you optimize the cost and the effectiveness that we have. It can be highly efficient. Watch your level of light transmission. And not that you can't have higher light transmission areas. There's spectacular designs that I've seen with these tall three-story areas, common areas. They should have very high light transmission. Absolutely. There are exceptions to everything that you talk about here. But in general, when we're just talking about office space or task space, then that's when this light transmission trade-off begins to harm the effects of what people can do in that space. Glare, it takes away the view. We got to close the blinds on the prettiest days, things like that. And we can control that basically with very little additional cost once you look at standard high-performance systems. We can really be creative in our glass designs, light transmission levels, and other things to help you do that properly. What I'm leaving with you is that it's really high performance, proper things, meet your design requirements in thermally broken systems, and harvest daylight as much as possible. Those are the things that make for the greatest value of what we can provide to you. and then certainly we can accommodate other things. Other things that go on that people are concerned about in glass and metal systems, low distortion. With suggestion is usually to use 8mm or 10mm glass. That will help you really eliminate the distortion, make the building more attractive. Avoid square sizes. Thermally strengthening square sizes is almost a physical, doing that without distortion is almost impossible. I throw that in for my manufacturing guys. Silkscreen patterns, metal design, all of these can help with the edge effects, the color of the pickup, the way you're being creative. Large sizes can be very dramatic, especially in these taller buildings, floor-to-ceiling glass, single units. There are limits to what can be done with these, and we have to be very careful about how they're designed. The glass does move, and there's a lot of things going on, but we do like to work with people and make sure that they understand it. Add features for natural light, I think, is one of the things that our industry can do a lot more of. So for designers, don't take air infiltration for granted. Be sure your owner's design for sustainability is looked at not just in the building, not just in the products, but in the total project. Because if we can help you lower the overall cost and drive efficiencies and meet your design requirements, there may be other ways to help get to a zero sustainability for your project. There are other things that can be done. We do many of these. We're happy to do them, as I said, but understand the cost and the benefit that comes with each of them as you design. So there's many great buildings. I think there's many in this audience who have them. You should understand why they're great, why they're performing well, and be creative as you challenge us in the industry to bring to you ever-improving products and things that we can do to make this work. And in the end, it's really all about the occupant. It's about that person who's assigning value. As Mayor Daley said, it's the value of buildings that drive everything that's going on. And it's those lease rates and occupancy rates, and it's the productivity. Those are the kinds of things that drive value, and we believe that we can help you do that today. So with that, I really appreciate the opportunities.
Thanks.